Quadratics. Again, this time we are focusing on completing the square method, a topic very challenging for most people. What exactly we mean by completing the square method? We have to go back into the mathematical history a bit. What I mean is that what is being taught in the initial classes of O levels, the basic maths that's being taught, let's focus on that. If I take few expressions such as x plus 1 whole square, x plus 2 whole square, and similarly x minus 3 and x minus 4 and x plus 5 and so on. All these expressions are of the form a minus b whole square and a plus b whole square. We know that a plus b whole square, a square plus 2ab plus b square, and a minus b whole square, that's a square minus 2ab plus b square. Now what have I done? I made a column for these 5 expansion. I made 2 columns. One column for the coefficient of x and the other column for the constant term. Is there any correlation between the coefficient of x and the constant term? As such, you don't feel any relationship. But what if you take half the coefficient of x and then you square those values? Coefficient of x is 2, half of 2 is 1. 1 square will give you the constant term. Coefficient of x in the second example is 4. Half of 4 is 2. 2 square is giving you 4. You're seeing a correlation being formed. Third, minus 6. Half of minus 6 is minus 3. Minus 3 square is 9. Minus 8. Half of minus 8 is minus 4. Minus 4 square is 16. Half of 10 is 5 and 5 square is 25. That means such expression of the form a plus b whole square or a minus b whole square. It is a must that the constant term should be square of half the coefficient of x. Remember this phrase, we'll be using it in a short while. Now in this particular expression, if I want it to be of the same category as the previous one, what I just said was constant term should be square of half the coefficient of x. Coefficient of x is 8, half of 8 is 4. What should go inside the bracket? 4, because there is already a square on the outside. That means I can then rewrite this thing as x plus 4 whole square. Because if I expand it, what do I get? X squared plus 4x plus 4x plus 16, which is the expression at the top. That means from x squared, simply pick the x. From 4 squared, simply pick the 4. If the coefficient of x is positive, it would be of the format a plus b whole square. If the coefficient of x is negative, it would be of the format x minus b whole square. Now, second example. X squared plus 14x plus something square. What should go there? 7. That means this will become x plus 7 whole square. And so on. You can look at more and more examples like this. Now this time, since the coefficient of x is negative, this is x minus 6 whole square. And in this particular example, x squared plus 3x plus something square, you would write half of that in the fraction form, that is 3 over 2. And the answer would be in the expression, the compressed form would be x plus 3 over 2 whole square. So our objective is taking a 3-term algebraic expression and reducing it down into a 2-term expression which has a square on the outside and x on the inside, a simple x with a coefficient of 1 and plus minus a constant term. Now these two things forms the basis of completing the square method. Y is equals to ax squared plus bx plus c, that's the general form. Y is equals to a x minus h whole square plus k, that is the standard form for the completing square method. A is the coefficient of x squared in the general form. A is still the coefficient of x squared in the completed square form. Now, what does A stand for? What does H stand for? What does K stands for? First of all, we would be doing the conversion. X squared plus 8x plus 6. the first and foremost rule. Make sure the coefficient of x square is 1. If it's not 1, make sure to take common. In this particular example, it's 1. Now, there is a mathematical rule which says that if you add something and you subtract the same thing, basically you are adding a 0. So the first two terms that I mean as x square and 8x, that remains the same. Push the constant to the side. First add, then subtract square of half the coefficient of x. Now the first three terms, you would reduce it and you would write this thing as x plus 4 whole square minus 16 plus 6, that is minus 10. Compare it with a, h and k. So you get a is 1, minus h is 4, therefore h is minus 4 and k is minus 10. So that's how you do the conversion. AHK would later be used for sketching based upon the factorized form. Right now, we are focusing on the conversion from completed square, from general to the completed square form. That brings a question in my mind and maybe in your mind too. How do you go about from completing square to the general form? The answer is very simple. Simply open up the bracket. That is not a big task. The big task is from general to the completed square form. Another example. Something like 2x square minus 12x plus 6. What is the first and the foremost rule? Make sure coefficient of x square is 1. Since it's not 1, you are taking 2 common throughout the equation. Repeat the same process on the inside. First add, then subtract square of half the coefficient of x. Rewrite the first three terms as a perfect square algebraic expression. That means the compressed form. That was the proper name for it. Perfect square algebraic expression. And we'll be using this terminology in increasing and decreasing functions. A chapter, a topic that links differentiation with quadratics. Make sure to multiply that constant on the outside with everything on the inside. And then again, you can compare it with the completed square form. Third example. This time, the coefficient of x square is negative 1. Even a negative is not acceptable. It is a must that the coefficient of x square should be 1. Second, that constant that you are adding and subtracting, that's in the fractional form. Fractions are part of life. There's nothing to worry about. All you have to worry about is your algebra. Open up the bracket. Compare with this thing, ax minus h whole square plus k. Fourth example. This time, the coefficient of x square is 3. The same process as before. Half of 4/3 is 2/3. And then it becomes secondary in nature. Open up the bracket with 3. And therefore, this thing is 3x plus 2/3 whole square plus 32 over 3. Now, the sketching part based upon factorized form. Sorry, this is completed square form. Factorized form was in the previous video of quadratic inequality. Y is equals to a, x minus h whole square plus k. If a is positive, happy face. Negative, sad face. H and k are the turning points. If it's a happy face graph, that turning point, that stationary point, that vertex, I have taken 3 names. Let me repeat it. Turning point means the same thing as stationary point, means the same thing as vertex. The word turning point is usually used in context of sketching, whereas stationary points, it's usually used in the context of differentiation. So h comma k is the coordinate of the turning point. Now again, throwing back a little bit light on quadratic inequality. Remember, we were using factorized form over there. Factorized form sketching was based upon 2 things, the shape and the roots. In contrast, the completed square form is based upon 2 things. Shape is still the same, but this time we are interested in the turning point and not in the roots. Now, x is equals to h, a line parallel to y-axis, that is the line of symmetry. If, for example, the examiner asks for what are the x-intercept, that's very simple. Whether a line or a curve cuts the x-axis y is equals to 0, If it cuts the y-axis, x is equals to 0. Now, let's focus on the sketch. Always compare with ax minus h whole square plus k. A is 1, happy face, h is 1 and k is 4. Therefore, simply draw a realistic graph. 1, 4 is the coordinate of the turning point. The graph is happy face. That is the lowest point. That is the minimum point through which the graph will pass, and you just draw the shape. Another example. Now this 3 on the outside, the value of a is 3. That changes nothing for us. Actually, it changes the steepness, but since we are drawing a graph, we are not comparing it with the original one. So therefore 3 means nothing for us. Minus h is plus 2. Therefore h is minus 2 and k is plus 1. So in the second quadrant, that's where your turning point is. It's still a happy face graph, and that's how you draw it. And these vertical dotted lines, what are they? They are the line of symmetry. Through which point they are passing? Naturally, they are passing through the turning point. How should the equation be written? The equation is written in the form x is equals to h, where h is the x coordinate of turning point. On the left, x is equals to 1. That is the equation of the vertical line. On the right, x is equals to minus 2. That's the equation of the line of symmetry. The vertical dotted line is the line of symmetry. More examples. This time there is a minus 1 on the outside. Second example, there is a minus 3 on the outside. What does that mean? Both graphs will be sad face graph. They will be graph having a maximum point, shape, that's all you care about. Line of symmetry, it's better that you draw it. Of course, if the examiner asks for it, you have to draw it. Otherwise, it's up to you. Now, past paper questions based upon completing the square method. Express the expression in the form ax plus b whole square plus c, where a, b, c are constants. Now, this is one thing that troubles student the most. What the examiner is trying to say, that change it into the completed square form. We will do that. The examiner is using his or her own symbol, ABC. What is the symbol that we use? We use AHK, that is the standard form. If the examiner asks for the turning point, you will always compare it with A, H and K. You won't be deceived by what the examiner is asking of you. If the examiner says, give me the value of A, B and C, based upon this, you would compare it with the examiner format. If the examiner asks for the stationary point, the vertex, the turning point, you would always compare it with the standard form. So that's how the working is. Just the same as before. You also know how to sketch it. If the examiner asks for it, when we will study functions, sketching plays an important part. So now A is positive, minimum. 3 minus 5 is the coordinate of the turning point, and if the examiner has asked for the sketch, that's how we draw it. Second example, this time the coefficient of x square is negative. Make sure to take that minus 1 common out. Make sure to do all the steps of completing square method properly. What were the steps? Listen to it again. Make sure coefficient of x square is 1. If it's not 1, take that coefficient common. Then on the inside, push the constant on the side. First add, then subtract square of half the coefficient of x. The first 3 terms you rewrite as a perfect square. Open up the bracket. Make sure to carry out justice. That means whatever the coefficient is on the outside, whether it's 2 or 3 or minus 1, multiply with everything on the inside. And if the examiner asks for it, you draw a sketch. Now the third example, we are interested in the first part. The second part was already solved in the previous video of quadratic inequality. This time, how is it different? Let me first carry out the method of completing the square. That's the same thing as before. But this time, what the examiner has asked us is that there is a 2 on the inside. The examiner is just asking for it. We have to obey and answer what the examiner is actually asking. The examiner is not asking for the turning point. If the examiner were to ask for the turning point, we would compare it with ax minus h whole square plus k. But the examiner wants the 2 on the inside. The examiner wants to know that what you have studied in O-level maths, the concept of indices, is it still fresh in your mind? Do you know how to apply it? You should know how to apply it. So therefore, the 4 on the outside can be written as 2 square and x minus 3 over 2 whole square. Now you multiply on the inside, keep the 2 on the outside. Which rule of indices is that? That rule is this: a power m, b power m. If the bases are different but the powers are the same, you can multiply on the inside and keep the power on the outside. So therefore, in this particular video of computing square, what were your aims and objectives? Your aim was to understand the methodology of converting from general to completed square form. That was the first and foremost thing. And the second thing was you have to draw a sketch based upon that. What were the precautions that need to be taken? Make sure your factorization is perfect. It's superb. Make sure when you open up the bracket, you carry out justice. Make sure you follow all the steps. Make sure that you don't get misled by what the examiner format is. Our standard format. That's not like our. That is the mathematical standard format. That is ax minus h whole square plus k. So whenever they are asking for the turning point, stationary point, vertex, you have to do the comparison with that particular format. That's it.